Okay, so let's get started. We're going to be taking a look at dialing in our transient fuel tuning within our Motec M1 programming. Now, transient fuel tuning is also known as acceleration enrichment tuning in other standalone systems. The idea here of what we're trying to accomplish will be the same as other standalone systems, meaning when we're going in and we have a large throttle rate change, so our throttle opens very quickly, we're going to have a momentary large burst of airflow, and we need to match that with a momentary large burst of a fuel pulse width so we don't have a lean tip-in condition. It can create a lot of drivability problems for us. That's going to be the general approach across every standalone system, even factory ECUs. However, when we're talking about Motec in terms of the programming, that is what we're trying to accomplish, but the modeling and the way we're going about this is completely different than other standalone systems. It's going to use a predictive type of system, and it's going to be modeling what fuel that we're losing, so to speak, in the fuel film that's going to stick to the intake track of our engine as we're spraying the fuel from our port fuel injectors. So the concept here is the same, but the way that Motec's going to calculate and do this is going to be completely different than other systems. So if you're used to doing acceleration enrichment tuning on another standalone, this is going to be a different concept and a different technique entirely. So we're going to walk through and demonstrate the process from start to finish here on our in-house test vehicle. Now, there are a few things that we need to understand before we head into dialing in our fuel film tuning. We need to make sure, first and foremost, that our volumetric efficiency table here has been dialed in 100%, meaning that at a given RPM and load threshold in our table that we are hitting the desired target lambda coming from our target lambda table. That means that our air and fuel model has been sorted out 100%. We also have our charge cooling gain that we have to make sure has been calibrated. We talked about how to do that in previous training modules in our training course. That has been taken care of at this point already. So I've dialed my volumetric efficiency table in here the best I can from 6,000 RPM and below. I've set up the charge cooling gain as well. The other variable or factor that we have to make sure is set up and dialed in here is going to be our injection timing. Now, the injection timing is something we've talked about in a previous module. I've actually went in and dialed all this in off camera. We will be taking a look at doing a fuel tuning demonstration coming up here shortly in the training course with the same vehicle here, and I'll walk you through how to dial in your fuel injection timing. But that also needs to be dialed in before we deal with our fuel film tuning. Now, the fuel injection timing is important because if we don't have it optimized and timed correctly for the engine we're working with and the location of the injectors, we'll find that we need more fuel flow within a transient type of condition, meaning we have to increase our injector pulse width more than we would otherwise if the injection timing has been optimized for our engine. So injection timing is important that we've taken care of that before we even jump into fuel film tuning. So VE table has to be dialed in, air fuel model has to be worked out. We're hitting the desired target lambda at any given load and RPM point. We have our injection timing optimized. We have our charge cooling gain taken care of. Then we can take a look at our fuel film tuning. This is probably one of the last things that we do within the calibration process in terms of our fuel tuning. Now, we do also have a few additional things that we have to make sure are in place before we jump into our fuel film model tuning. We need to make sure that our closed loop lambda here has been disabled. Normally we want to run our engine with this enable. We want to keep this on, and we've talked about how to set this up and configure everything and use it for calibrating and tuning purposes. But when we're talking about fuel film model tuning, we cannot have the closed loop enabled because it can skew the results. So we want to make sure that we're in open loop and that we have our closed loop turned off. The other variable here, our overrun cut, should also be disabled. So we should not have our overrun cut enabled. We should have it in disabled state right now so we can dial everything in. Now we will be going in and we will be taking a look at turning the overrun cut on to be able to dial in a certain singular parameter within the transient fuel film model tuning. But for right now, we do want to have our mode here set to not in use. So closed loops disabled, overrun is disabled. We also, jumping in here to our fuel tuning, want to make sure that our target aim, target lambda table is set here from 100 kPa and below to 0.9 lambda. This is something I'm doing specifically for the fuel film calibration process. This is not something I'm going to leave permanently in my target aim table, but this is what I'm going to set it at for right now so we can get a feel for dialing in our fuel film. This is important because we have to have a fixed lambda that we're calibrating at and a fixed RPM that we're calibrating at in order to sort out our fuel film. All right, so we have our target lambda set. We have the VE table here dialed in pretty well. We'll be going over this real quick just to make sure this is 100%, specifically at 2000 RPM. That's going to be our test RPM point. We want to make sure this is 100% because we have something called a fuel film calculator that can allow us to actually sort out and dial in our fuel film tuning and get it pretty close. And we want to make sure the accuracy of that calculator is correct based on what we have in terms of our reference RPM, based on our VE values, making sure airflow and fuel model are 100%. So at a given load point, we are hitting the desired target lambda in open loop perfectly. This will make more sense as we go through here and start to do the demonstration. So we're now going to move from our fuel tuning page and jump over here to transient tuning. Our transient tuning is where we do all of our fuel film model tuning. Now again, as I was mentioning, we have our port fuel injector spraying the fuel into our engine. When that port fuel injection is happening and we're spraying that fuel, some fuel is going to make its way into the engine, some fuel is going to stick to the intake track, and then some fuel will also evaporate in the intake track. We need to account for the fuel that's sticking to the intake port. Now, how much fuel film is going to stick is going to depend on engine temperature, port temperature, engine speed, airflow, manifold vacuum, injector placement, the type of fuel that we're dealing with, a lot of variables. So Motec is going to model this and allow us to account for the fuel film that's sticking into the intake port. Now under steady state conditions, so we're just driving in steady state and we have our normal VE values here in our table dialed in, our fueling is going to be consistent because the amount of fuel that's going to stick to the intake track and also evaporate is going to be a consistent amount, meaning as we dial in and tune our VE table here, we can get completely repeatable and consistent results with our fueling. But when we're in a transient situation, so we crack the throttle open very quickly, we're going to find that the steady state fueling here is not going to work because we're not accounting for the difference of how that fuel is sticking to the intake track and also evaporating, the ratio there, and also getting into the engine. So that's where the fuel film modeling is going to come into play.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.